Good morning, students. I hope you are aware of what we had studied last time. We were talking about different systems, and since we have covered up the topics on pipelines, like the jacket cooling water, steam lines, all those things. Today we are going to touch upon the ballast and deballasting system. So this is again going to deal with the pipelines. Now here, this is going to deal with the saltwater pipelines. So you know saltwater pipelines, you need your pipelines which is connected with the sea chest. So shall we see how the water is entering into the ship, and from the ship how it is going into the tank. That's called ballasting. And for deballasting, you have to remove the water which has already gone into the tank, and from there it is being pumped into the sea. Okay, so here basically let us see the diagram and also look into the places from where the water can be sucked from the sea. So shall we have a look at the diagram? So here we have the hull of the ship. Over here we have the high sea section, we have the low sea section. So here we have the high sea, and that's for your low sea section. Now basically the idea of having this high sea and low sea, one must very clearly understand. This high sea section normally is used when your cargo is loaded. Cargo is loaded, of course. But this particular thing you use only when your ship is in the port. Whereas when the ship is out at sea, you are going to use a low sea section. So if this is your sea level, we have the high sea section which is for your port requirement, and the low sea section for your out at sea, or when your ship is going deep in the ocean. Now you may ask me why we are going in for this high sea and low sea. We can't use low sea when the ship is in the port. Why? Because the depth of the seabed in the port is very less. So there are all possibilities of muck going into the low sea section and finally entering into the system. And once these muck enters into the system, you know what will be the consequence. They will go and jam up your pipelines, your valves will start malfunctioning, your pumps will also start malfunctioning, and you have a whole lot of problems. So that's the reason why we don't go in for this low sea section when the ship is in the port. And when the ship is in the port, that's the time when you are going to carry out your activities, ballasting and deballasting. Fine. So here you are going to ballast the ship. When do you think you are going to ballast the ship? When the ship cargo is being discharged. So when the ship's cargo is being discharged, you are going to ballast the tanks. Right? Why is that so? You are going to bring about stability of the ship. Now what do you understand by that? You are going to fill up the water so that the frames of the ship is not affected, which is very, very important. Please mind. The frames are the ones which is your backbone on which your hull is building. So we don't want any of those frames to be affected with stress and strain. Now what really happens is, when you have your frames over here, if the force of the water is much more over here, what will happen? This is going to get a force and is going to bend it upwards. That's called hogging. Or if the load is more over here and this beam is coming down, it's called sagging. So this hog and sag is the one which is going to affect the frames, and we can't afford to lose the strength of your frames, because if they are lost, your ship is in danger, because there are all possibilities of your plates getting damaged, mainly because the ribs have gone, or the frames have gone, and minor incident is sufficient enough, or supposing even if ship is expected to hit a bad weather condition, she'll be ripped off. That's the reason why more importance is given to this. I hope you have understood this. So let us go into the aspects. We have seen what is high C section. We have also seen what is low C section. When to use them is also realized. Okay. Now here what happens is, this is the place from where your pipelines are getting connected through valves, through filters, and finally entering into your pump. So this is your C filter. And you also have inlet valve and an outlet valve of the filter. This filter also plays a very important role, please mind you, because we don't want any of your microorganisms to enter into our system. So you have these filters which will filter out any of these things. And finally, it is going over here. But here you also see there is one more thing that is attached. What is it? That is your vent. Why do we need a vent? Now here, if this vent is there, what will happen is, I don't want any airlock to take place. So what do? I open up this vent, or I open up this valve. What happens is, the head, sea water level head, is sufficient enough to rush into the pipelines. Once it rushes into the pipelines, and I open up this valve, what happens is, if there is any air, that is being pushed out from here. So that's your vent. I hope it is clear. So if the air trap is there, and if you are not allowing this air to escape in the vent, what will happen? The quantity of water that is entering in will be inconsistent. So I don't want such things to happen. So I have to ensure that the vent is opened up, no air is there, and see to it that the water flow is continuous. And so when I do that, your water is issuing out of this vent pipe continuously. Once I ensure that, which means I ensure that your filter is filled up, I close this one. Once I do that, then I go to the pump suction and the pump discharge. Once I go to the pump discharge, and after that I have to ensure that which tank has to go, whether it has to go to the port side, whether it has to go to the starboard side, or whether it has to go to both port and starboard. Okay. Now why do I say that it has to go to both port and starboard? Whenever you are ballasting the tank, you should ensure that your ship is always upright. Mind you, your ship should not list to this side or that side. Why? Because you are also discharging your cargo. So here you have to ensure that the water which is filling up into the tanks are equal and that they are not affecting the list of the ship, which is primary. So here I ensure that the water which is going into the double bottom tanks, this will be your DB tanks, port and starboard. So I will ensure that the water is entering into the port side tank and the starboard tank equally. This would, of course, see to it that it is maintaining the listing of the ship to a large extent. So here we have done this, and finally you have this pipelines, which is your pump suction, and this is your pump discharge. So let us go back. I am going to open up your IC section. We are just going to repeat so that you don't forget. So here we have this IC section line being opened up. When you are going to ballast the ship, open up this valve before and after the filter. Ensure that the air has been removed out from the filters. The water is issuing out from this vent. Having confirmed, you are going to close this valve. And once that is done, you open up your suction valve of the pump, discharge valve of the pump, and also the intermediate valves and the valves which is going into the port side or the starboard side. So here what we do is, we see that the valves are opened up and finally start the pump. But there is a peculiar characteristic as far as this centrifugal pump is concerned. Mind you, I should also tell you that as far as this pump, your ballast pump is concerned, we are going to use only centrifugal pump. Okay? Can anyone tell why? Yes, you're right. It's because we have to pump in volume of water and we don't need any pressure. That is the reason why we are using this dynamic pump, which is also your centrifugal pump. Okay. This centrifugal pump is going to pump in volume of water into the tank, because we know for certain that the tanks, your ballast tanks, contain is about 5,000 and 6,000 liters of meter cube of water. So here you've got to have large capacity pumps. I hope it is clear now. If you are going to use your positive displacement pump, what you get is only pressure. So we don't want any pressure over here. We want volume, and that's the reason why we are using this centrifugal pump or dynamic pumps for pumping water into the tank. I hope it is clear. Now, once having done that, you are going to start the pump. Now, the peculiar characteristic of a centrifugal pump is you can keep your discharge valve shut, start the pump, and ensure that you also have a vent pipe over here. So I open up the vent over here and see to it that the water is coming out, and slowly open up the discharge valve. So once I open up the discharge valve, I also make a note of the discharge pressure. You have your suction pressure, you have your discharge pressure. So this is your pressure gauge. So during the pressure gauge, you will find out that the volume of water which is passing through, there is sufficient amount of pressure being generated. So this is going to ensure that. And over here, having opened up these valves, I am going to send the water to both port side as well as on the starboard side. So once I see that the water is going on to the port side and the starboard side, I need to get a feedback from the deck side saying that the water is going into the respective tanks regularly. And how will I do that? Because these people on the deck are going to take sounding. Now, what is sounding? Sounding is nothing but a flexible tape with a bob weight down below, and that is dropped down into the tank. And once it is dropped down into the tank, this bob weight strikes the bottommost portion plate. So once it goes into the striker plate, you will realize that the scale has reached the bottom, and you take the measurement. So it is something like this. I just got to draw a schematic diagram for you to understand as to how we take the sounding. Assuming that this is your tank, this is closed. You have your sounding tape which is going over here, and this is the striker plate. And that's your tape. your sounding tape, which is also measured in centimeters as well as inches. Normally go for centimeters. So this striker plate goes and strikes the bob, this is the weight. This goes and strikes the plate, and once that is done, you then measure the total height. And now here what happens is, how will you come to know how much liquid is there inside the tank? When I drag this up over here, I keep observing, and this portion to this portion will be wet, which is what I'm going to read. And once I read that, I find out how much is the quantity of water that is gone in. So when you know that the quantity of water, you get it in say centimeters or meters. How will you know how much quantity of water is there inside the tank? Now try and understand, as far as this measurement is concerned, you also have a calibration table. So this calibration table this is available for all the tanks. Okay. The shipbuilder himself gives you the measurement of all the tanks, right from 0 centimeters or 0 millimeters to about say 1.5 or 2 meters height. So at each point you come to know. When you know that the height is this, then if that is the height, I go to the table over here. Once I go to the table, get the measurement, and from here I will be able to get how much quantity of water is there inside this ballast tank. So I go to the respective tank name, in this case port side number 5, starboard side number 5. I go there, find out how much quantity of water has gone in. Okay. Besides, I think I also told you that when you are putting the water into the tanks, there should not be any change or listing of your ship either to the port or to the starboard. If there is any change in that, what would happen is the readings over here on the port side and the starboard side will vary. So you have to maintain the ship in upright condition. So if you can maintain the ship in upright condition, you are able to get the exact quantity of water which has gone in. I hope it's clear. Now you may say, now your loading is going on and so the ship trim is also taking place. Yes, you are right. Ship trim is also taking up. So in that case, again, in the calibration table, they also make provision for the listing, for the heating of the ship. So once your ship has trim forward or aft, depending on that, you will be able to calculate the quantity of water that is there inside the tank. I hope it is clear. Apart from that, this tank is also provided with a wind. So when you are filling up, ensure that your water is only up to this point over here and do not see that the water is overflowing from the wind tank. That's mainly because this is at the bottommost portion of your ship. And your sounding pipe which is coming in over here, if your sounding pipe is getting filled up, there is too much pressure coming onto your tanks. So it is said that when it comes to about 90-95% of your ship's tank capacity, please try and stop it. Okay? And see that you don't overflow. I hope you have understood the reason why I am asking you not to fill up or overflow tank. Right? So once you have done that, you are ensured that the water is going into the tanks. I hope it is clear. So that is as far as your ballasting system is concerned. Any doubt is there, you please make a note of it so that when we come to the next class, we will be able to discuss those points also. I hope it is clear. Can I have this on now? I hope. Now that is as far as the tank is called ballasting. Now let us go to the other one, the aspect of what is deballasting. The word de means removing. So I am going to remove whatever water that is there inside the tank. So I have a tank over here. Outside tank, that's an outside tank. And I want to remove the water from here. What's the method? So over here, with a simple schematic diagram, I have a pipeline which is getting connected to the suction side of the pump. I have those respective valves. With the help of the respective valves, the tank which is filled up, valves are opened up, respective valves are opened up, and finally it comes onto the suction side of the pump. I hope it is clear. I want to remove the water from these tanks. What I do is I open up the respective valves, get it connected to the suction side of the pump. These valves over here, as far as your filter valves, etc. This is shut. Why is that so? Because I don't want this seawater to go into the tank. I want to remove the water from the tank itself. Okay? So here I have the reverse process taking place. Water has to be pumped out from here to the sea. So I have this connection over here. I hope this diagram is quite simple for you to understand. From here, it is connected to the suction side of the pump. And when I start the pump, what happens is the water starts going out to the discharge side. So I open up the discharge side of the valve. And I have to ensure that this is going overboard. Overboard, outside. So it's a very simple thing. Water is drawn from here through the suction side of the pump. I start the pump. From here, the water is going out. Now, having understood this, I have large quantity of water inside the tank. Pump is able to draw the suction and it is pumping it out. Fine, so far so good. But now, what happens is, after some time, the water level is going to come down. Once the water level comes down, this pump is going to lose its suction. So when it is going to lose its suction, and you take the measurement of these tanks, you may find that the tank in few centimeters, say about 10 centimeters of water is there in both sides and the starboard side. Now, it may appear very insignificant, but when you go into your calculation table and find out the quantity of water that is remaining inside the tank is quite large. So here, I can't afford to have that much quantity of water, which could be into 50 to 100 tons in each tank. Okay. So I have to ensure that that quantity of water is also getting pumped out. But please understand, the pump is not taking suction. So here, there is another arrangement for the tanks to be stripped. So that is called stripping. So whatever little water that is there inside the tank, that can be stripped. And how do we do that? So just modify this diagram again. So whatever little quantity of water that is available over here has to be pumped out. Now here the procedure is slightly different. I have to ensure that the water is coming from the sea chest. This is your high sea or your low sea. In this case, we have already said that it is to be high sea. So from the high sea, I have to open this valve. Before filter, after filter, pump suction, pump discharge. And now I don't allow the water to go into this tank. So what happens is there is a bypass valve. This valve is shut. I don't allow the water to go over here. So this is shut. Now there is another line. When I start this pump, there is another line which is going over here. Into a stripping arrangement. So here what you see over here is a divergent, convergent nozzle. Okay. This is your divergent, this is your convergent. And from here, the water over here, when you open up this valve, when I start this pump, water from here is going in over here, make it pass through this, and from here it is getting directed over here. So I'll have to ensure that if there is a valve over here, this needs to be shut. Now you understand why it has to be shut? I want the pump to run through the stripping system. And so when it is to move through the stripping system, you can see that the seawater is made to pass through the pump, through this valve over here, and through the stripping arrangement and finally go overboard. I don't want this because what will happen in this case, this will create a shortcut and will not pass through this. Now if you can understand this, when it is passing through this point over here, what really happens is when it is moving at a good force, it creates vacuum on the annular space of the nozzle. So when there is a low pressure being generated on these annular spaces, this space is what is connected to our tanks. So I have a valve. So in this case, what I do is I take only one tank at a time. I open up this valve over here, this tank valve over here. I open up this stripping system arrangement valve over here. When I ensure that the seawater is passing through this, which creates a low pressure, since this line is connected to the low pressure zone, what really happens is this water is getting sucked. Something like you drink your soft drinks, you suck through the straw. And similarly, you have the water which is getting sucked over here, and finally it goes overboard. In a similar fashion, once this tank is stripped completely, I take the measurement, find out there is no water there, I go to the second tank, open up this, and follow the same procedure. So this is your stripping arrangement. Okay. This is very important because stripping is the one which helps you to reduce the quantity of water to zero level, so that you are able to take more cargo on the ship. I hope it is clear. This is the process by which you carry out your ballasting, your deballasting, and I should add one more, and stripping. The last part that we have discussed is your stripping arrangement. I hope it is clear now. Fine. Now, as far as there's one more aspect before we close this topic, we have another aspect on this as far as this ballast pump is concerned. Generally, ballast pumps are large capacity pumps, and having this large capacity pumps, there is an additional responsibility for this pump also. Here, what happens is there is one line which is also connected to it. That's an engine room flow plate, and this is the plate. Supposing if there is any flooding taking place over here, I have this water passing through this point over here, I also have an emergency built suction valve. So here I have an emergency built suction valve which is connected to the suction side of the pump, which is going to take the water from here, passing it to the pump, and from the pump what happens is I have the line which is going in over here. All unnecessary valves are going to be shut. So in this case, I am going to shut this valve which is going into the next. I am also going to shut the valve which is going into the receiving system. I have to open up this valve which will lead me to the overload valve. So I open up this overload valve, this valve, and finally pump it out. So what really happens is when we use this? This particular system is used when your engine room gets flooded. So once your engine room gets flooded, this pump is used to pump out the water from here. Okay. And why? Because this is a large capacity pump. You never know, the ingress of water into the engine room could be large. And so you have to save it, in order to save the ship from damage to other machineries, you have to take up this step. Okay. Of course, there are other aspects also which needs to be discussed. We will do that in the next class, which tells you about the engine room water which is being pumped out and what are the other steps that we need to take. I hope it is clear, and please see to it that you are drawing all these schematic diagrams so that you will be able to understand them well. Okay? Thank you.